Hey guys, so this video is on proportional relationships, specifically multiple forms of representation. So how do we show a proportional relationship, the same relationship in all four of these ways? So like a scenario, so that'd be like a word problem, an equation, a table, and a graph. Okay, so we can see the same relationship, the same situation happening, but we can show it in multiple ways. We can show it in words, an equation, a table, or a graph. So if we want to just talk about something simple, okay, let's talk about something not too complicated. For example, I can drive at 45 miles per hour. Okay, that would be my situation. Like I'm driving a car, I'm trying to get somewhere, and I'm going at a rate of 45 miles per hour, and I'm on cruise, so I'm not going any faster or any slower. It's just 45 miles for every hour. What would my equation be for the situation? Y equals 45x. So maybe the amount of miles I travel y is 45 times the number of hours I travel. What would be my table? So let's say in 1 hour, I travel 45 miles. What about in 2 hours? I travel 90 miles. In 3 hours, I travel 135 miles. Where x is the number of hours that I'm traveling, and y is how far I get. To put it on a graph. Okay, so a graph might be what this x-axis is the number of hours I'm traveling. So this is hours. 1, 2, 3. And then my y-axis would be the number of miles I'm traveling. We can go by, here I'll go by 50s so that we can fit more on here. Okay, so in 1 hour I travel 45. In 2 hours I travel 90. In 3 hours I travel 135, somewhere like right there. Okay, and then we can see that this is proportionate because at 0 hours, I travel nowhere, right? So proportionate graphs, proportionate relationships have to include that 0, 0, but then it's also a straight line. Every single hour, I'm traveling 45 miles per hour. So every single one of these shows the same situation, that I travel 45 miles per hour, and I can show it in words, maybe a fuller word problem or a situation, that I didn't write there, but in words, a scenario, an equation, a table, and a graph. So what we're practicing in this video is connecting those four things. If I gave you this graph, could you figure out what table matched it? Or if I gave you the table, could you figure out the equation? Could you figure out the graph? And vice versa, okay? So can you connect the four different types of representation if given one of these things? Right, this time let's look at this graph and let's try to figure out the equation and the table that goes with it. So given this graph, the equation that we're using for these proportional relationships, which we know is a straight line that includes the origin, the equation that we use is y equals mx. Okay, y equals mx. M is the only part of this equation that you're changing. That m is your slope. Remember, slope is the level of steepness of your function. Okay, so this line, this relationship is a function. This is our linear equation. This is our linear function. M is your slope. So how steep is this line? Is it very steep? Is it positive? Is it negative? Is it completely flat and 0? So the only thing you're changing in this equation is m. M represents slope. How steep is this line? To figure out your slope, we're going to use rise over run. So if you're given a graph, we're going to use rise over run. That means you're going to find some perfect points, which means these are points that have integer ordered pairs, not points where it's a decimal or somewhere in between. And you're going to go from left to right. We know this is a positive slope because from left to right, just like we read from left to right, it's going up. So from any leftmost point to the next right point, what is the rise over run? So we are going up and over. For this one, the rise over run is, so to get from this point right here, we have to go up 1 and over 1, 2. Okay, so this is up 1 over 2. And that's actually going to work for this entire line. The slope is going to be constant because it's a straight line. If the slope wasn't constant, it would be a squiggle of some sort. So up 1 over 2, you can see that this is going to work again. Up 1 over 1, 2. Right? Up 1 over 2, up 1 over 2. So it's kind of like a staircase. So our rise over run is up 1 over 2. It's going to be positive because it's going up. So our equation for this graph is y equals 1 over 2x. The only thing I changed was that variable m. M represents slope. To put this in a table, your x, y table are ordered pairs. So these perfect points we have here, that's your x, y table. That is your ratio table. So I'm going to include this first point right here, which is -2, -1. So when x is -2, y is -1. We have the origin 0, 0, because this is proportionate. It has to have 0, 0. Our next point is 2, 1. So when x is 2, y is 1. And then our next point is 1, 2, 3, 4. It's a little off. That should be 4. Should be like right there. So when x is 4, y is 2. Okay, so these ordered pairs, where do you see the connection between a table and a graph? These ordered pairs, or these x, y values, are ordered pairs. They're your points on your graph. Okay, so if you were given this table, this ratio table, you should be able to match the graph because these are ordered pairs. That's your point. These are all points. Okay, or vice versa. If I gave you this graph, you should be able to tell me the equation. You should be able to tell me the table because you have those points. You have those x and y values. Now, one thing I wanted to show you is the slope. We started with the graph, we figured out the slope, and we put it into our equation. But where do we see this equation or the slope in this table? I'm going to get rid of these. Where do we see that slope in the values of our table? Because all three things are connected, right? They're all connected. So where do we see it? Y is half of your x. That's what this equation is saying. Your y is half of whatever your x is. So if my x were -2, what's half of -2? -1. If my y was 0, what's half of 0? 0. If my y was 2, what's half of 2? 1. What's half of 4? 2. If I give you some random point that's not even on this graph, if x were 54, what would my y be? What is half of 54? 27. Okay, so if you have this equation, you should also be able to figure out what table matches that. Because your equation tells you your relationship between your x and your y. So what's happening is x is half, or sorry, your y is half of your x. Okay, so you're basically multiplying this times a half. Okay, another connection I want to make. Rise over run. We have the slope a half. Where does this rise over run? Where do we see this rise over run in this table? I know the slope is a half, so if I take half of x as my y, where's my rise over run? Right down here. When you rise on the graph, you are changing your y value, right? Because the y-axis is what goes up and down. So when you are rising, or even if you're falling, if it's a negative slope, your rise is what's happening on your y-axis. Are you going up? By how much? Are you going down? And by how much? So we're going to use this delta y. That means your change in your y. Whatever your change in y is. In this case, we're going up 1 every time. Your run, when you go across your graph, you're going across the x-axis. You're moving left and right. You're really moving to the right. We're always moving to the right. So how much do we go over? That's going to be your change in your x-axis, or your delta x. That's what this delta means. This delta means change. Okay, change. So if we're looking at this table, how is my y changing? How is my x changing? Let's just zoom in right here. because it's easy when we have that 0, 0. How is my y changing? From 0 to the next point, 1. How is it changing? It's changing by 1. From my x value, from the first point, 0, 0, to my next point, how is my x changing? Well, it went up too. So your change in your y over your change in your x is 1 over 2. That's your rise over run on your graph. So that is how we see those connections between all these representations. These representations represent the same thing. It's the same problem. It's the same situation. Up 1 over 2, you see that in your graph. You see it on your table. You see it in your equation. It's all the same thing. It's multiple forms of representation for a proportional relationship. Let's do another one. Now, which one of these graphs represents the same relationship of this equation right here? Y equals negative 3x. Your equation tells you what's happening going across from your x, from your x to your y, what's happening. Okay, so this is negative 3 times x. So your y is negative 3 times x. That means going across, which one is time? Actually, I'm not going to use the time. I'm not going to use x because that's a variable. I'm going to use the dot. Times negative 3. Which one is times negative 3 going across? For every single row. So you got to check them because that's our rule up here. Okay, negative 2 times negative 3. Is that negative 6? No, it's not. So this one's out. That's not right. Negative 4 times the negative 3. Is that positive 12? Do you know your integer operations? These are integer operations. Negative 2 times the negative 3. Is that 6? 0 times, oh yeah. 2 times negative 3. Negative 6? Oh yeah, that one looks right. Let's check this one. Negative 1 times negative 3 is 3. 0, that's going to be 0. 1 times negative 3 is not positive 3. That messed it up. That should have been negative. Okay, so this one is not right. Okay, so the relationship going across should be this right here. This is times negative 3. Let's think about this in terms of the slope. Okay, if this is the equation, what is the slope? That's the equation. Slope is m. That number. Remember, that's the only thing we're changing in our equation y equals mx. That number right there is your slope. That's m. M is negative 3. And when you have a whole number like this, and if this were to be on a graph, where's your rise over run? Okay, that's just a single integer. So all whole numbers can be put over 1. So if you're on a graph and you see that it's over 1, you don't even need to include that either, because negative 3 divided by 1 is still just negative 3. But I want to show you where you can see your slope in your table. Okay, so if this slope is negative 3, 1, remember our slope is your rise over run. When we rise or fall, that's the change in your y-axis. If we go over our run, that's going to be your change in your x-axis. So we're saying, this equation says that our change in our y is negative 3. That means we're going down 3, and then we're going to go over 1. So if I had a graph to get from point to point this way, it's going to be down 3 over 1, down 3 over 1. So you could make a graph, or you could match a graph to this. But let's zoom in. Let's zoom in right here. I like using that 0. It's easy to see what's going on with 0. How do we get from 6 to 0? What's my change in my y? Okay, I went down 6. What's my change in my x? My run. I went up 2. Okay, so my slope is going to be negative 6 over 2. But I thought you said the slope was negative 3 over 1. We can simplify this to negative 3 over 1, which is the same thing as negative 3. So it all connects. Given this table, what is the equation? And what's the slope? Let's do both. What is the equation? What is the slope? The equation is some sort of multiplication or division rule from your x to your y. So given these x values, what sort of multiplication or division happens to get from these x values to these y values? I see that they're getting smaller. So we're dividing by something. What are we dividing by? 4 divided by what? Is 1. 4 divided by 4. 8 divided by 4 is 2. 12 divided by 4 is 3. Okay, so that works out. If you have a hard time seeing that division pattern going from x to y, okay, you can also look for a multiplication pattern from going from y to x. Just know that your equation is going to be from your x to your y. Okay, so if you can't see it that way, we'll look this way. Well, how do I get from 1 to 4 times 4? So going the opposite way must be divide by 4. So if we're dividing by 4, my equation is going to be y equals 1/4 x. This 1/4, remember, is my rise over run. This is my slope. My slope is 1/4. That means on a graph, it would go up 1 over 4, up 1 over 4. Where do we see this on the table? Let's just zoom in on any one of these two. What's my change in y? Up 1. What's my change in x? Over 4. So that's where you see that up 1 over 4. You can do, let's do it down here too, just so you see. Different color. Well, from these 2 points. What's my change in y? Up 1. What's my change in x? Over 4. Up 1 over 4. Okay. Another variation of these multiple forms of representation is that you have the situation, it tells you what it wants, and then you're going to have to put it on the graph. So this is not quite a word problem because there's no context to this, but that's still a skill we need. So graph a line that passes through the point 3, 2 and has a slope of 2. So if you have a function that's going through 3, 2, well then that means 3, 2 is one of our points. So I'm going to go ahead and start with 3, 2. That means right 3, 1, 2, 3, and up 2, 1, 2, right here. This is that point 3, 2. Okay. If it has a slope of 2, what am I doing? So I know m is going to be 2. What does this mean in terms of rise over run? Remember, all whole numbers can be put over 1. And we say just slope of 2 because 2 divided by 1 is 2. So we want to make things as simple as possible in math. But to see that rise over run, you need to put it over 1 if you see a whole number. So this is your rise over your run. So if I have that starting point, well, I'm going to go up 2 and over 1. Up 2 over, up. So let me redraw that. It's a little off. There we go. That's 3, 2. And then I'm going to go up 2, 1, 2, over 1. You know, your graphs will be a little bit easier to graph because you'll see the grid lines. But again, I can go up 2, over 1. Okay, and you really only need 2 points. That point, this point right here that it gives you, and then one more point using your rise over run in order to then draw yourself your function, your line. Can't see that very well. Something like that, but straight. Okay. Let's do another one. This time it's a line that passes through this point, -4, 5. And this time we have a negative slope. I just want to make sure that you know what that negative slope looks like. So I'm going to start here. This is one of my points. If you're going to draw a line, you really only need 2 points. So we're going to start with that original point, -4, 5. So -4 to left 4, and then up 5 to 5. Okay, so right there. And then if it has a slope of -3 over 4, m is -3 over 4. That's going to be your rise over your run. So anytime it's negative, I want you to put that negative up top in your numerator because that's your fall. We're not going up because it's a negative slope. So we know it's going to be angled down. So you're going to go down 3, but we're always reading from left to right. So down 3 and then over 4. Okay, down 3 over 4. So we're going to go down 3, 1, 2, 3, and then over 4 would put us right here. And you could do it again. You could go down 3 and over 4 again. 1, 2, 3, over 4 here. But you really only need 2 points in order to draw yourself a line. So anytime it gives you, oh my goodness, that was terrible. It's got to be straight, okay? It's a straight line. Anytime it gives you a point that it has to pass through, start there and then do your slope. Starting from that point, do your rise over run or your fall over your run. I think it might be too low. Oops. I'll draw another graph. All right, just wanted to take some time to make sure you know the 4 different types of slope. Okay, so slope, we're always looking at a line from left to right, just like we read from left to right, even though your line will have an arrow pointing in both directions. So what does undefined look like? Undefined is a line that is straight up and down. Okay, anywhere in your graph, if it's straight up and down, that is undefined. A little bit sloppy. Okay, undefined. What does it look like? Or what is the slope if it's straight across? Straight across like that. Anywhere in your graph, straight across. It can even be on the x-axis, straight across. Your slope is 0. Okay, think about if you're standing on this line and you're walking there on this nice flat line. There is no incline. It's 0 slope. Okay, what about this? That is positive because it's going up. From left to right, it's going up. Some people are like, well, Michelle, from right here, it's going down. It looks like it's going down. This arrow is pointing down. But from left to right, if we start on this left arrowhead and we go to the right arrowhead, what's happening? It's going up. So this one's going to be positive. What about this one? Up. Okay, starting from the left arrowhead to the right, going to the right, it's going down. So this one is negative. I also want to say that for positive and negative, it can be very flat, almost 0, but still positive. So something like that. Okay, do you see that one? This one right here. It's pretty flat. Flatter than that one. This pink one's steeper. It's flatter, but it's still going up. Okay, so even if it's like just ever so slightly up, that's positive. Okay, it's just the rise over run is not going to be as, it's not going to be as extreme as something that's really steep. Or something that's really steep even. Okay, that's, oh, I forgot, you can't see that far down. Something like this. Okay, or like this. It's still going up. That's still positive. And same goes for the negatives. As soon as it dips down negative, okay, even just a little bit, it's negative. Right before this unit, we learned about proportional relationships, and we learned about how we can set proportional relationships up and how we can solve for a missing part of our 2 fractions that equal each other. And in that unit, we saw vertical and horizontal tables, but I also wanted to make sure that we knew that we could see these in both ways. Okay, so this is the same relationship. X is 2, y is 10. You can see x is 2, y is 10. We have 4 and 20, 4 and 20, 5 and 25, 5 and 25. It's the same relationship. You can see ratio tables or input-output tables, XY tables, however you want to say it, vertically or horizontally. But you're going to do the same thing to figure out your equation or plot your points. This is still an ordered pair, 2, 10. You can still put 2, 10 on a coordinate plane. Even if it's written like this, your x value is 2, your y value is 10, so it's still 2, 10. You can still put it on a graph. For your equation, remember we're trying to figure out some sort of multiplication or division rule going from x to y. If your table is horizontal, you're just going down. What do I have to do this to get 10? Times 5, right? It's times 5 going down. That's times 5, times 5, times 5. That's what we see up here too. This is times 5, times 5, times 5. So what's my equation for both of these tables? Y equals 5x. This is a whole number, so if we were to figure out our rise over run, that's that 5 over 1. So that means I would plot a point, and then I would go up 5 over 1, up 5 over 1. If it asks you for m, slope, that's 5. Okay, so this is the equation, that is the slope.